All right. Congratulations, guys. We're going to go with red because we're at the last two problems. This is the last podcast for this worksheet. Yeehaw. All right. These problems are just a little bit longer because we're figuring out excess reacting. So let's go and look at this one. Hydrogen, that's H2. Hydrogen gas reacts with nitrogen, that's nitrogen gas, N2, to make ammonia, which is NH3. So to balance this, we have to put a 2 there, and a 1 there, and a 3 there. All right. So the question is, we have 8.5 liters of hydrogen, 8.5 liters of hydrogen, and 5.4 liters of nitrogen. And we're trying to figure out how many liters of ammonia we get. Okay, and then we're trying to work our way back to figure out excess reactant. So let's go and do this. We have 8.5 liters of hydrogen gas. And we have to get rid of liters of hydrogen gas and go to moles of hydrogen. And from moles of hydrogen, we go to moles of ammonia, which is NH3. And from moles of ammonia, which is NH3, we go to liters of ammonia, because that's what we're asked for. We're asked for how many liters of ammonia. We have to go liters of ammonia. Okay, well, 22.4 liters in a mole, and our hydrogen has a 3 in front of it, our ammonia has a 2 in front of it, and 1 mole is 22.4 liters, so our liters are going to cancel, and we're left with 5.7 liters of ammonia. All right, well, we have to do this again because we have to do it for our 5.4 liters of nitrogen. So we start with 5.4 liters of nitrogen. That's nitrogen gas. We're going to do something that looks very, very similar here. 22.4 liters of nitrogen gas and 1 mole of nitrogen gas. And then we have to go from moles of nitrogen gas to moles of ammonia. And then we have to go from moles of ammonia to liters of ammonia. And in front of the N2 we have a 1. In front of the NH3 we have a 2. We have 22.4 here and 1 there. So again, our 22.4 is canceled, so we take our 5.4 and multiply by 2, and we get 10.8 liters. And because we only have 2 sig figs, that's going to round to 11 liters of NH3. Right. So clearly, this is our limiting reactant. We can only have 5.7 liters that came out. So when you subtract, you take 11 and you subtract 5.7, you end up with, that would be a total of 5, right? It's actually 5.3. But you have to round to 5 because there's no digit out there, so it's 5 liters. So we're going to start with 5 liters because that's what you have in excess. That's what you were not able to make. Okay? You were able to make 5.7, but this one, you could have made 10.8. The difference there is 5.1, but we have to round to 5 because of sig figs. So we have 5 liters of NH3 that we were not able to make. So now we have to work our way backwards from liters of NH3 back to moles of NH3. And then we have to go from moles of NH3. Let's stop for a second. We ran out of hydrogen, so that means we have nitrogen left over, so we have to work our way back to moles of nitrogen, because that's what we had in excess. And then we have to get rid of moles of nitrogen and go to liters of nitrogen. And let's see, 22.4 liters in a mole, 22.4 liters in a mole, and in front of nitrogen we have a 1, and in front of NH3 we have a 2. So we take the 5, and it's 1/2, so it's essentially 2.5 liters, 2.5, 2.5. If you want to round it for sig fig purposes, you end up with 3, but either way, liters of NH3. Okay? I'm sorry, of N2. My bad. N2. That's what you did not use. Okay, last one. We have a 2.25 gram sample of aluminum sulfate. Ooh, yuck. Aluminum sulfate. AlSO4 reacts with sodium phosphate, another yuck, PO4, to make some 1 gram of precipitate. Well, what's going to happen? Well, clearly this is going to be a double replacement reaction, aluminum phosphate and sodium sulfate. All right, well now let's balance our charges. Aluminum's +3, sulfate is -2. So it's aluminum, here we go. Sodium phosphate is +1 -3, so I have to crisscross there. +3 -3, they cancel. +1 -2, so I have to put a 2 there. All right, I immediately notice that I have 2 sodiums on one side and 3 on the other, so that means I have to have 6 of those. I now have 3 sulfates. I have to have 2 aluminums. I have to have 2 phosphates. I am now balanced. Okay, so what am I doing? Well, sodium phosphate is aqueous. I know that because it contains sodium. And sodium sulfate is aqueous. So this precipitate must be the aluminum phosphate. And aluminum sulfate better be aqueous when it's over here. So when you do this, you can look up on your solubility table and you'll figure out that aluminum phosphate is, in fact, the solid. All right, so we have 2.25 grams of aluminum sulfate and 3.25 grams of sodium phosphate, and we're making 1 gram of this stuff. All right, so let's go back and actually do our stoichiometry problem. 2.25 grams of aluminum sulfate, and I have to convert from grams of aluminum sulfate to moles of aluminum sulfate, and then I have to go from moles of aluminum sulfate to moles of our target, where in our case our target is the solid, so it's aluminum phosphate. And I have to go from moles of aluminum phosphate to grams of aluminum phosphate, because I have to be able to compare against the 1 gram that they're talking about that they got in the chemical reaction in the lab. So let's go put in some numbers here. We have to put in a 342.15 grams. We have to figure that out. And our aluminum sulfate has a 1 in front of it, and our aluminum phosphate has a 2 in front of it. And 1 mole of aluminum phosphate weighs 121.954 grams. When I do the math here, I get 1.60 grams of aluminum phosphate. Okay, let's do it again. And this time we're starting with 3.25 grams of sodium phosphate. Let's see what happens here. I have to figure out which one is limiting. So we go from grams of sodium phosphate to moles of sodium phosphate. We go from moles of sodium phosphate to moles of aluminum phosphate. Now we go from moles of aluminum phosphate to grams of aluminum phosphate. Well, those last 3 things we can copy from directly above, 121.954 in 1 mole. And we have 2 moles of aluminum phosphate. We have 2 moles of sodium phosphate and 1 mole of sodium phosphate. We have to figure out how much that weighs, and that's 163.94. When we actually do the math, we come up with 2.42 grams of aluminum phosphate. So that tells us this is our limiting reactant. The maximum amount we can expect to get out of this reaction is 1.60 grams. But it tells us that we only got 1.0 grams. So we got 1.0 grams divided by 1.60 grams. And when we have to multiply that by 100 because we're dealing with a percentage. And that's going to give us 63%. And you'll notice that we only have 2 sig figs up here in the 1.0. So we have 2 sig figs in our answer. And that's it, folks. Congratulations. You have finished. That's the end of these podcasts. End of the unit. Have a great day. If you have questions, please see one of us in class. We'll be happy to help you. Take care. Bye-bye.